The miter gauge that came with your table saw is probably not very good, but in this episode we're going to show you how to turn it into an accurate, precision cutting tool. In this episode, we're going to be drilling and tapping some mild steel and cutting some aluminum rod stock. Nothing terribly difficult, but these do raise some safety concerns that you'll need to be aware of. Your carbide saw blades are perfectly capable of cutting aluminum stock, but the chips tend to be hot, heavy, and sharp. So I always recommend using a full face shield when cutting aluminum stock, and long sleeves aren't a bad idea either. Drilling and tapping the mild steel is relatively straightforward, and we'll show you how to do it, but you do want to be aware of the metal shavings and burrs that can be left behind. Wood splinters are terrible, but metal shavings can be even worse. As always, in your shop, you are responsible for your own safety, and your best safety device is up here. You are your own best protection. Unless this is the first episode of Wood Academy you've ever seen, you'll know that I own and use the Osborne EB3 aftermarket miter gauge for most of the cutting around my shop. But not everyone has the wherewithal or even the need for a high-end aftermarket miter gauge. Sadly, the miter gauges that come with our table saws are usually not terribly accurate, and we're going to fix that. I'm going to show you how to accurize your miter gauge. And even if you do have an aftermarket gauge that you use for most of your cutting, the miter gauge that comes with your saw makes an excellent basis for jigs and fixtures to be used on your table saw. Using my stock miter gauge as the basis for all of the various jigs that I like to use on my table saw simplifies the entire process. I don't have to reinvent the wheel every time I need a new jig. Now, whether you're going to use your stock miter gauge as an auxiliary like I do, or as your primary cross-cutting device, if it's not accurate, your results aren't going to be accurate. So we're going to take a couple of steps here to tune up the miter gauge to create as accurate a cutting device as we possibly can for just a few dollars. Factory, aftermarket, or shop made, if your miter bar doesn't fit the slot properly, you simply can't get accurate results. Much of the work here is going to be done on the bar, so the miter gauge has to be disassembled first. The locking handle is removed by simply unscrewing it completely, and then the T-slot retaining washer removed if your miter gauge has one. Most gauges have some sort of flip stop for the preset angle cuts and a pointer to indicate the angle. They both need to be removed, and on mine, this is a single set screw for both. The head of the miter gauge can now be removed. A shoulder bolt mounted to the bar acts as both the pivot point and to hold the head in place. But be careful here. Many miter gauges have a set screw in the face of the head to lock this shoulder bolt in place. The set screws used for the 90 and 45-degree presets are removed next. Now any repairs can be completed. The flip stop for the preset angles usually gets pretty banged up. I used one of my Bessie C-clamps as a press to flatten it out. And that worked perfectly well. The bar and the head are both checked for damage. Any burrs or damage are filed out, and all of the parts get a thorough cleaning. The restored miter bar is measured for actual width. Then the micrometer is set to exactly half that measurement and used to scribe a line down the center of the bar. This line is then filled in using paint or a wax pencil, as I'm doing here. Then the surface of the bar is buffed, leaving a sharp, precise, and easily seen line right down the middle of the bar. Now with our bar cleaned up, the center line marked, and everything still stripped off it, this is the time to adjust the bar to fit the miter slot. Now, you will see in some magazines and other online sources, they'll use a punch to hammer the edge of the bar to leave a little divot that can then be filed down until it fits. I don't like the idea of altering my bar, and then as that wears, and it will, you're going to have to keep doing it over and over again. It's really not a permanent solution. So what we're going to do is actually drill through the bar and use some nylon set screws to adjust the width of the overall bar until we get a perfect fit in our miter slot. For less than $30, I was able to buy a 1032 tap, the proper drill bit that goes with that tap. They are matched, so you want to make sure you get the right size, and some nylon set screws, also 1032. These are a little bit harder to find than metal set screws, but I do prefer them because they're less likely to scratch up the shoulders of my miter slot. And as they wear, and they will wear first, which is what we want, as they wear, we can just readjust them. Now, we're going to drill all the way through the bar and tap all the way through the bar. This is a mild steel bar, so that's just fine. We can do that. But that allows me to use the set screws in the bar, reach in from the other side with an Allen wrench to adjust and not damage the Allen screw opening. We're going to use the bottom of the set screw to rub against our miter slot. So it's not that difficult to do, but this is when you want to do it while the bar is off the miter gauge and cleaned up. Now the other thing is that I've got a T-slot, miter slot here. I want to make sure that the set screws are centered on the shoulder rather than on the bar, because there's the slot underneath and I don't want the set screws to be meeting up with that. But that's not hard to do. It's very clear here from the wear pattern where the slot is and where the shoulder of the miter gauge is. I'm just going to drill my holes right centered on that, and then everything should work from there. You got to take your time. It's going to use some 3-in-1 oil or some other lubricant to do the tapping, but we should be able to do that without too many problems in the average shop. Through holes are drilled first, and it's important that they're perpendicular to the bar. Ensure that your drill press table is set up properly. A drill press vise, like the Bessie unit I'm using here, is a big help. The bar will drill pretty easily, but take your time and let the bit do the work. Clear the hole regularly to remove chips, and a few drops of oil in the hole will keep things lubricated and greatly extend your bit life. 3 holes should be drilled, 1 toward the front, 1 in the middle, and 1 toward the back. The exact locations are not really important. Just make sure that your new holes don't interfere with any of the existing holes in your miter bar. You do need to be a bit careful working around the chips and curls that come off of the bit. They are sharp. Countersinking the holes will remove any burrs and make starting the tap a little bit easier. The tap is mounted into a tap handle and a little bit of oil applied to the threads. The end of the tap is tapered to start cutting the threads gradually. Set the tap by hand, making sure that it's aligned with the hole. Then gently turn the tap with a rod through the tap handle. The handle comes with a rod, but mine is missing, so I'm using a screwdriver. The tap is made from hardened steel, so it's hard enough to cut threads in the mild steel, but it's also brittle. Working it carefully will cut good threads without breaking the tap. The proper technique is to turn the handle until the tap starts to bind. Then turn it backwards a partial revolution and reverse again to go back to cutting threads. And then, every several revolutions, back the tap out completely and clear the threads. Just take your time, keep things lubricated, and don't rush the process, and you'll get great results. With the holes threaded, the set screws can be inserted. Thread them in until they're inside the bar. They'll be adjusted later. The protractor head is reinstalled on the bar, and all of the other components added as well. Add the angle pointer, but don't lock it in place yet. And all of the other components reinstalled as well. The protractor head, pointer, flip stop, and the 3 set screws for the preset angles are all now installed, but they have to be calibrated. And that's one of the reasons that this line was established on the bar. A simple, clear plastic protractor from the office supply store can be lined up on the head and then adjusted until the center point on the flat bar is against the head and the white line is in the middle of that indicator. Then the head can be adjusted until the 90-degree mark up here aligns with that line as well. Now the head is at 90 degrees to the bar. The handle can then be reset in place, locking the bar in. The pointer is now adjusted to the scale on the protractor head and locked in place. And while it's at 90 degrees, the flip stop can be put into position and the set screw adjusted so that it's just touching the flip stop. It'll take a little bit of adjustment here to get it to the point where when you bring the head back to 90, it meets, but it's worth doing. Once set up and calibrated, the flip stop is moved into position, the head brought back to the 90 position when the two touch, and this can be verified using our protractor, and that looks good. So now it's really easy to return this protractor head back to 90 after making an angled cut. And the stops for the 45-degree angles are done the same way. Using the protractor and the scribed line on the bar to set the 45, lock it in place, and then adjust the set screw. The set screws are now adjusted to fit the bar to the miter slot. Adjust the set screws in sequence, front to back, so that each slides easily within the miter slot without any side-to-side play. Your miter bar is now clean, tuned, and adjusted to provide accurate results. The only thing your miter gauge lacks is a good auxiliary fence, and this one ticks all the boxes. It can slide back and forth to be set wherever needed, tied up against the blade, even during angle cuts, or crossing over the blade to back up your cuts to give a better finish. It has a T-slot across the top, so a flip stop can be added anywhere along its length, and it features an extending end that can slide in and out to allow you to do repetitive cuts for longer pieces. And this fence is not nearly as difficult to build as it might appear. The T-slot across the top and the holes that run all the way along the length of the fence that the rods will run in for the extension are easy to do because the fence is made of 2 pieces of plywood milled to the proper shape and then glued together to include those details. Start by ripping 2 sections of good quality 3/4 plywood. They should be about 3 inches wide, and the length can be whatever makes sense for your saw. The inside faces of these 2 pieces get milled on the router table with a 3/8 inch diameter round nose bit. Check the fit as you go by clamping the 2 rods between the fence pieces. Adjusting the milling setup as needed until the rods slide freely within the grooves. The measured drawings in the plans for this project were based on this particular miter gauge. The miter gauge on your saw may require adjusting some of these dimensions. There are a number of ways for adding the T-slot to the top of the fence, but since we're gluing the fence up from 2 pieces, it can be done quickly and efficiently at the table saw. 2 passes across each face forms the T, and the channel of the slot is created with a vertical cut down each face. The 2 pieces of the fence are now glued together. The glue is applied sparingly. There's a lot of surface area here. The trick is to keep the glue out of the channels. The aluminum rods are replaced in the channels before the faces are assembled. They will keep everything accurately aligned while the parts are glued together. Double check to ensure everything is aligned and moving freely. Then fully clamp everything securely while the glue cures. Next, the aluminum rods are removed, the ends of the fence are trimmed, and a 4-inch section cut off one end to serve as the extension block. The aluminum rods are marked to 1 inch less than the overall fence length and can be easily cut at either the table saw or the miter saw. Rough sand about 4 inches at the end of each of the rods. Then they're epoxied into the extension block. The fully mixed epoxy is added to the holes and spread as evenly as possible. The bottom of an empty soda can is excellent for mixing up a small amount of epoxy like this. Excess epoxy is wiped away, and the rods inserted into the holes. Turning the rods as they're fed into the holes helps to ensure complete glue coverage between the rods and the block. Work the rod all the way through the extension block, wipe off any excess epoxy, and then flush the ends together. And set the entire assembly on a piece of wax paper until the epoxy is fully cured. Epoxy should be more than enough by itself to keep the rods in the extension block. But just to be safe, they can be pinned in place by driving a brad through a small pilot hole drilled through the block, through the rod, and then into the other side of the block. The fence attaches to the miter gauge using these dovetail hardware pieces. These are the studs from Microjig. It's a brand new product, and it really makes this process much simpler. We just cut a dovetail groove into the back side of the fence. It slides onto the studs, and then they're just tightened up. And they don't even have to be tight, just snug, and they'll lock in. And this allows for sliding the fence back and forth across the miter gauge for whatever cut I need to make, and then I could just snug it up again, and it's tight.
A relief is cut to remove most of the waste before milling the dovetail groove. This is a 1/2 inch, 14-degree dovetail groove, 3/8 of an inch deep, per microjig's instructions. The mounting holes on this miter gauge were pretty close to the top of the protractor head, so a nylon spacer was added to provide clearance for the knob that comes with the dovetail hardware. To complete the fence, a clamp is added to hold the extension in position during use. A 3/8 inch diameter hole was bored into the back of the fence along the line of the top rod. A piece of wooden dowel prevents blowout when the two holes meet. A brass 1/4-20 threaded insert is mounted in this hole for the 1/4-20 brass thumb screw that will actually lock the rod. The threaded insert has a slot across the top for using a screwdriver. But a much better method is to put a pair of jam nuts on a 1/4-20 Allen head bolt and use that to drive the insert.
The T-slot across the top is to accept a flip stop. This is Rockler's flip stop. It uses a 1/4-20 T-bolt, which slides right into our groove. And this can be positioned anywhere along the fence needed, and then used as needed for repetitive length cuts. It can also extend out into the extension block where it travels with that for longer cuts. So this gives us maximum flexibility, and it's easy and accurate and not terribly expensive to buy.
The factory miter gauge that came with your saw is now a safe and accurate cross-cutting tool.
Here's a pro tip for using your new and improved factory miter gauge. The line that was scribed along the bar earlier and used to calibrate the 45 and 90-degree stops can also be used with the office protractor to set any angle quickly and remarkably accurately. The head can be turned, and then the center point of the protractor aligned with that line, and in this case 22.5 degrees, and then realign the center there. And the angle can be quickly and accurately set up that way.
Woodcademy is made possible with the generous support of our sponsors. Please take a minute and let them know how much you appreciate it.